In the got it section of number 5, again we have to get rid of the i's. I'm hoping you notice that part B will be the easiest one because it has a monomial on the bottom. Let's work with A first. Okay, so apparently I made a mistake when we got to problem 5, got it, 5A. I don't think I messed this up, but let's go ahead and just redo the whole problem. Now I have an assistant, Ben, with me. I just told you your name.
Yeah,
is
thanks.
that okay? Okay. You don't know his last name, so all you know is that he's Ben. All right, talk to me, Ben. Tell me what I need to multiply by in part A.
Looks like you need to multiply by 3 minus 4i over 3 minus 4i.
Now, Ben, what do we call that 3 minus 4i? It starts with a C. C-O-N. C-O-N-J. I think, right? C-O-N-J? C-O-N-J U-G-A-T-E.
Conjugate.
The conjugate! That is correct. Very good.
I am terrible.
You're not terrible. Nobody can see you, so they don't know who you are. It's okay. And you did set it right anyway. All right, now on the top, we are going to have to what? Now listen to what he says because he will not say FOIL.
Okay, you'll multiply the binomials.
Good. What do we get?
5 times 3 is 15.
Good.
5 times 4i is negative 4i. It is negative 20i.
That is correct. And what about, we got to keep going. Hold on, I want to move that around. All right, we're ready. What about these two now?
Okay, we've got negative 6i.
Good. And then these two.
8i squared.
That is correct. Now we'll deal with that 8i squared in a moment. For now, let's go to the bottom and not FOIL, but
Multiply the binomials.
that is correct. Go ahead. This one times this one.
9.
Good. And then the outsides, please.
12i.
Yep, a minus.
Minus 12i. Yeah.
And the insides, please.
12i.
Good.
Plus 12i.
And then the last and the last, please.
Negative 16i.
Do better. Negative 16i.
Squared.
That is correct. Now we're going to fix the bottom. Let's do the bottom first. What do you notice about the middle two terms?
They cancel each other out.
Very good. And what do you notice about minus 16i squared?
It turns into positive 16i. Oh, it's just positive 16.
That is correct. Now let's talk about the top. What happens to the positive 8i squared?
That turns into negative 8.
That is correct. Now we'll combine our like terms on both the top and the bottom. On the top we have 15 minus 8, which makes
7.
That is correct. And then we have a minus 20 and a minus 6.
Negative 26i.
That is correct. Alright, on the bottom we have 9 plus 16.
25.
That is correct. Now we always need to check and see if anything reduces. Ben, does anything here reduce?
No.
No, that is correct. This is our final answer. Let's take a look then. If you wait for the video, you'll see that we'll fix part B. Part B wasn't wrong, so we'll probably do these out of order, but you'll be fine. We'll come back to it. All right, part C, Ben. What do we have to multiply by to get rid of the I this time?
8 minus 7i.
On the top? Oh, go ahead. I'm sorry.
On both top and bottom.
Very good. Notice how, guys, he did not change the top. He didn't care what the numerator was. He simply used what we call the what of the denominator, Ben.
Conjugate?
That is correct, the conjugate of the top and the bottom. So I'm going to let you tell me all 4 terms on the top. I will write them as you say them.
Okay, 64 minus 56i minus 56i
Very good.
and plus 49i squared.
That is correct. Now let's take a look at the bottom. Ready? Go ahead.
64
Good.
minus 56i
Good.
plus 56i
Good.
and minus is 49i squared.
Good. Now let's go ahead on the bottom and tell me what happens to the middle 2 terms.
They cancel out.
And that always happens when we use a conjugate. And talk about a minus 49i squared for me.
Turns into plus 49.
That is correct. So on the top, we need to go ahead and combine these. And I think this is where I made my mistake in the last video. Can you tell me, let's start with this. What does that box, plus 49i squared, what does that turn into?
Negative 49.
That is correct, because I squared is what, Ben?
Negative 1.
That is correct. Now let's put all our like terms together. 64 minus 49.
15.
That is correct. And now we need to put the i's together. What's a negative 56 and a negative 56 make?
Negative 112.
Good, and that has an I on it. Now we'll look at the denominator. We have a 64 and a 49 that need to be added up.
113.
All right. Now, Ben, does anything cancel out of the 15, the 112, and the 113?
Nope.
That is correct. That is the end. Thank you for your assistance. Say bye.
Bye.
All right, part B will be a little easier. Just multiply by what you want to get rid of. Some students try to multiply by 6i, which is fine, but it actually makes it a lot harder in the end. You just want to get rid of the I, so just multiply by the I. Distribute in. 4 times I is 4i. Minus I times I is minus I squared. On the bottom, 6i times I is 6i squared. Let's fix the top. Minus I squared turns into plus 1. So the top becomes 1 plus 4i. The bottom becomes a negative 6. Now we should really never have a negative on the bottom, so nothing else cancels, which means I'm just going to take a negative and divide it through every single part, because you really never want a negative on the bottom. In problem 6, you have to know how to factor using imaginary numbers. Let's start by pulling out a GCF, which is what you should do all the time. The GCF is 2, which leaves you with x squared plus 16. Now if this was x squared minus 16, as a side note, okay, if it was x squared minus 16, you guys would do x plus 4 and x minus 4. But it's not x squared minus 16, it's x squared plus 16. Alright, if that's the case, you're going to still use plus and minus. You're still going to use 4 and 4. But this time, you're going to use I and I with the 4. And if you want to see why that works out, let's just go ahead. Ready? Under this line, we'll do the check. X times x is x squared. X times negative 4i is minus 4ix. Positive 4i times x is plus 4ix. And then positive 4i and negative 4i is minus 16i squared, which turns into a plus 16. The 4i's would cancel out, and that proves that you would get x squared plus 16. So you guys have always heard of it. So far, you've always heard of it called the difference of perfect squares. And you know how to factor those. But today you learned how to do the sum of perfect squares. Let's try it again. Look at the got it and take out a GCF if you can. You should take out a 5 and you'll be left with x squared plus 4. Why would that be beneficial? Because you know that these are perfect squares. This is the sum of perfect squares. If you ever have the sum of perfect squares, you do x plus and x minus. 4 breaks down to 2 and 2, but because it's the sum of perfect squares, you would need to do 2i and 2i. We're on the last page, and now I think this is actually one of the easier pages of your notes. Finding solutions using imaginary numbers. You're still going to use your quadratic formula. So if you kind of miss the quadratic formula, it's back. And it's really going to be pretty simple. We talked about the basics of imaginary numbers, and you're just going to apply that into your quadratic. Alright, let's say that we have 2x squared minus 3x plus 5. If you can factor that, go for it. But can you? No. There is no way you're ever going to figure out what goes in there. No way you'll figure out what goes in there. If that's the case, you must apply, ready, the quadratic formula. If you can't factor it, use the quadratic formula. You can complete the square if you want, but I find that miserable. Let's go ahead and start with the quadratic. Negative b plus or minus square root of b squared minus 4ac all over 2a. Now let's plug in. Opposite b is a positive 3. Plus or minus the square root of all that stuff in there. B squared minus 4ac all over 2 times a. This should be nothing new to you. The only part that's new to you is when you do the stuff inside, you get a negative inside. You've never seen that. You've never seen when there's a negative number inside. Well, guys, the only thing you do is you pull out an I. That's it. You pull out an I. Let's try this in the got it. Alright, you cannot factor this. Okay, there is nothing that you guys are going to be able to think of that will ever factor this. So, we're going to use the quadratic formula. Okay, we have A, B, and C. So, ready? Opposite B, positive 1. Plus or minus the square root of b squared is 1, minus 4 times a, which is 3, times c, which is 2, all over 2 times a, which is 3. Let's keep working that out. That is going to be 1 plus or minus the square root of 1 minus 4 times 3 times 2 is going to be negative 23. All over 6. That's going to be 1 plus or minus I square roots of 23 all over 6. Do a quick check. Does 23 break down at all? Maybe like 4 times anything or 9 times anything? No. 23 does not break down. Nothing reduces. So that's your final answer. Part B is going to be a little bit different because you actually have an answer, a better answer. Okay, so we're going to do negative b, positive 4, plus or minus the square root of b squared is 16, minus 4 times a, which is 1, times c, which is 5, over 2 times a, which is 1. Keep working. That's 4 plus or minus the square root of 16 minus 4 times 1 times 5 is actually 16 minus 20. So that's a negative 4 inside, all over 2. I really hope that you guys know the square root of 4, right? Everybody knows the square root of 4 is 2. So let's keep going. But you knew that without me telling you. 4 plus or minus, now this is 2i, because the square root of 4 is 2, but it's imaginary, all over 2. Now you see all these outside numbers, they each reduce by a factor of 2. Because they each reduce by a factor of 2, we just write 4 plus or minus 1i. The 2's cancel out. I have one extra problem to help you along with your homework. Okay, because I thought A and B were pretty simple. I thought they kind of gave it to you nice and neat. Let's look one that maybe isn't so nice and neat. You have to, you guys remember this, set equal to 0. That's going to be just a basic instinct now, is set these things equal to 0. Which means you have to distribute in. 2x squared minus 6x equals negative 5. And now you have to add 5 over. 2x squared minus 6x plus 5 equals 0. Now it's ready to go. Negative b plus or minus the square root of b squared, 36, minus 4 times a, which is 2, c, which is 5, all over 2a, which is 2 times 2. Let's carry this over, follow the arrow. That's going to be 6 plus or minus the square root of all of that stuff in there becomes a minus 4. Make sure you know how to add and subtract. All over 4. Well, that's going to equal 6 plus or minus, I know you guys know the square root of 4 is 2. This is the imaginary though, so 2i all over 4. Every single thing reduces by 2, so you write 3 plus or minus I over 2 as your final answer. So you can see that you can either factor, if you can always factor, I would not use the completing the square. I would always go to quadratic if you don't know how to factor it.